welcome to another episode of Empower Apps. I'm your host, Leo DM. Today, I'm joined by Marc Prud'hommeaux. Marc, thank you so much for coming on the show.
Thanks for inviting me, Liam.
Before we begin, I'll let you go ahead and introduce yourself.
Yeah, my name is Marc Prud'hommeaux. I am one of the co-founders of Skip.Tools, which is a development environment and tool set that enables iOS developers to build their applications for Android.
How did you get started with this idea?
Well, I've been building apps since the very beginning of the App Store, going all the way back to 2008. Mostly iOS, but also some Android. Me and both my co-founder, Abe, in this venture, together back in 2008, we actually together wrote the first ebook reader for the iPhone called Stanza. And that was a pretty big hit. And, one of the things after we got, 1 million users that we kept getting questions about is, when is Android going to be available? When are you going to, have an Android version? And we always wanted that. But, when you're coming from a really small team, it's, a really big ask to write your app a second time, for Android. And that's always been the case. Stanza wound up getting acquired by Amazon, and Abe and I worked for Amazon for a while, and then we sort of went our own ways. Abe worked at Twitter, head of platform development, iOS platform development there. And I, have done various things, working on dozens of different app projects, some really big, like the New York Times and Bose, and some fairly small. But always we've been faced with this prospect of clients who want to build their application for iOS first, because iOS is really, captures the vast majority of the, dollars in terms of people who spend money, on or through applications. But Android is the other half of the mobile ecosystem. And, people always come into it, very often saying, okay, we'll design the iOS application first, and then Android will be TBD. And then when it comes time to actually implement that Android side, that's when people start making hard decisions and asking tough questions. Do we bring on a second team? Do we rewrite the whole thing in some cross-platform framework? And there has been no real satisfactory answer up until now. So that's kind of the long roundabout way that we got to identify this, need that I think all the app developers universally have having experienced themselves.
So how does it differ? How does Skip.Tools differ from something like Flutter or React Native or Xamarin, for instance?
Yeah, I mean, so those have historically been the really big three names in cross-platform app development frameworks. In general, all three of these application development scenarios bring in their own individual way of building applications. Flutter, which is backed by Google, you develop using Dart, which is their really bespoke language that is mostly just used for building Flutter applications. React Native, you write it in JavaScript. That's Facebook's framework, and Microsoft Xamarin, or more recently re-evolved as Maui. Yeah, you write in C#. And so all three of these languages and frameworks are really alien for both iOS and for Android. They're both bringing in their entire, alien development stack. You really need to know those languages and really want to develop in those languages. The big difference with Skip is that you write your application in Swift and in Swift UI, just using Xcode. You build and you run your app on iOS. And Skip on iOS doesn't actually do anything at all. We don't intrude into the framework. You're writing direct Swift UI using Apple's own Swift UI. Where we really differ comes into how we implement the other half of the platform story, the Android half. And that is where Skip takes your Swift code and it builds it for Android. Initially, the current sort of mature version of Swift 1.0 is that it transpiles all of your Swift code into Kotlin. And transpilation is just the process by which we parse your Swift code and we convert it into Kotlin code, and we output that, and then we build that for Android. And the end result is that on Android, we wind up taking, your Swift and turning that into Kotlin. We also wind up taking your Swift UI and turning that into Jetpack Compose. And Jetpack Compose is Android's, modern declarative user interface language. It is the Google recommended way of building Android apps. And they're very similar. So it's possible basically to take a Swift UI view and convert that semantic view into the equivalent Android semantic view. And that's what we do. And so the end result is that you don't have, one of these sort of uncanny valley Flutter applications where it's kind of mimicking the native platform experience and things like that. We have real, honest to goodness native apps using both of the platform's common recommended idioms.
So I just want to kind of like clarify how Flutter is building directly to machine code. It's like kind of using core image to kind of, or C or Objective-C to basically write directly on the screen. I'm not sure how React Native works. And my experience with React Native hasn't exactly been positive. I feel like if it does work, it's amazing when it does. But I'm not sure if that's like a HTML web view, or how, do you have an idea on how React Native works behind the scenes?
Yeah. So you're right with Flutter. I mean, Flutter is actually just drawing every individual pixel on the screen. And then they have, a variety of sort of themes that you can apply. Like they have one that called the Cupertino theme that sort of makes, sliders look like iOS native sliders, and sort of makes text boxes kind of look like text boxes. Enough to sort of pass the screenshot test and be like, that looks sort of native, and that's good enough. React Native is different. They actually do wind up rendering onto native controls, but they're using the React layout system. They're basically using CSS flex boxes to lay out the components and get them to, show up on the screen in kind of the same way that you'd write a web page, but instead of rendering to HTML elements, they're kind of rendering to, text fields and, sliders and things like that.
And then Xamarin or Maui, I would assume is more like, I don't know, kind of compiling directly to an app, and then it has a bunch of extensions added on top of it.
Yeah, that's right. Okay. So React Native, they are all JavaScript, and it winds up just being interpreted on the device and their JavaScript interpreter. But Flutter and Xamarin, they both do compile down to, machine code, and they're shipped as binaries. But they also do have garbage collectors built in. So it is kind of a Java-ish scenario on both iOS and on Android.
That makes total sense. So as somebody who has never developed an app for Android, I kind of wanted to cover a few things that iOS developers may not know about. So let's start off by saying, what are like some major differences that you've seen with Kotlin and Swift?
Well, they really come from the same next generation kind of language push. Kotlin has replaced Java for Android development, just as Swift has more or less replaced Objective-C development for iOS. And both of these languages, are very, heavily stressed type inference and, declarative design. Kotlin is, I always say if you squint hard enough, Swift looks just like Kotlin. You can say, var x equals ABC, func do thing, and then, arrow return value. There's a couple of fairly minor syntactic differences, but you can sort of cobble together a hello world main program in Kotlin, and it looks a lot like Swift. So it's similar enough that you can imagine just writing a regular expression or something and taking your Swift program and turning it into Kotlin. The more advanced things like generics and converting value types like structs and things like that, some of these don't have an exact equivalent in Kotlin, and that's where the translation of the Swift into Kotlin starts to get really, really complex. And that's where the Skip plugin does all heavy lifting for you.
So is there like, they don't have generics quite the same way that Swift does?
Yeah, generics work fairly different. Simple basic generics work more or less the same. You can have a
Okay.
collection that is, on a generic type.
Associated types. Okay, I could see how that would be kind of a pickle.
Yeah, but and generics on protocols do wind up getting implemented fairly differently on interfaces in Kotlin. Interfaces are the equivalent there. And then on top of all of this, the fact that Kotlin is built on top of Java and is running in a JVM, regardless of where you're running it, be it on Android or on the server or on your desktop. Java has historically made these very controversial decision to erase your types. So they do this thing called type erasure. So those types don't actually exist to the knowledge of the runtime environment. Yeah. And so that means that we have to tack on a good amount of metadata in order to be able to accomplish some of the things that come naturally with Swift, where you do always know, what the generic type is at runtime.
So what are kind of like, are there any performance disadvantages with using Swift?
Swift or Kotlin?
With using Swift and then having it transpiled with all the additional metadata and such?
Not really. We attempt to, distill things down, compile things as idiomatically as we possibly can. Kotlin in general, it is a garbage collected environment, and they have no native value types. There's no equivalent to a struct or an enum in Swift. So, what we have to do is we have to wind up translating, your structs and your enums, your value types, into classes in Kotlin in such a way that it preserves the copy and write semantics that Swift offers you. And so that is going to be not as efficient as the Swift version. I mean, it's not. It's turning it into Kotlin. It's running, on a JVM. It's garbage collected. But that being said, we have never really encountered performance issues with it because, in general, Android is designed to accommodate this sort of, additional memory overhead. The higher watermark, the garbage collection, and things like that. The statistic that I read is that on average, the equivalent sort of quality Android phone to, their iOS version, the premium, levels and the mid levels, they tend to have twice as much RAM as the equivalent iPhone version does. And that is largely to accommodate, the additional memory overhead that you need for Java and Kotlin applications to run.
That makes total sense. So let's move on to the UI part. What's the big differences between Jetpack Compose and Swift UI?
Well, as with, I say squint hard enough and Swift looks like Kotlin, squint hard enough and Swift UI looks like Jetpack Compose. You have to squint a little harder because, the structure of Jetpack Compose, Swift sets up views in a hierarchy of these structs, and these structs have a body. And the body might have, a V stack that contains a text field and a slider and a button. In Jetpack Compose, you more or less have that same sort of declarative outline of your views. Difference is that they're done in global functions and top-level functions rather than in views. Yeah, and so those functions are the things that sort of track the state access that takes place inside of them and marks those. Once the state gets marked as dirty, marks those as being needed for what they call recomposition. And recomposition is essentially where the view knows that it
Redraws.
needs to. Yeah, exactly. It needs to redraw.
I was gonna say a big thing is like you're losing a lot of the power of generics. And do they even have a DSL in Jetpack Compose?
They not quite like as good as Swift does. They're really working more with what they have in Kotlin, but they do have a compose compiler. You mark your functions as what they call composable, and that winds up being run as a Kotlin compiler plugin once it is being built in. Yeah. It's a lot like a macro. And so these composable functions, they have additional metadata that's tacked onto them, basically a context that's being passed through that has, hooks that grant access to all of your state, to, all of your environment, all the things that it needs to know in order to be able to, know when you need to recompose these views.
So how, like, so I did actually build an app. I followed through on the
Right.
example, and it was like I recently ordered a Pixel 4a because I
Oh,
wanted
cool.
something cheap and like
Yeah.
small to work with, and built, and it was amazing. How does like the build process work on Android different from like Xcode build and deploying to like a real device?
Right, right. So, again, Android has all these mirrors to what we have in the iOS development world. Swift has Kotlin, Swift UI has Jetpack Compose. In addition, Swift Package Manager has an equivalent in the Kotlin world called Gradle. And Gradle is an ancient build tool that goes back really, to early times. Used to be done in Groovy. Now its native DSL is Kotlin itself. Similar to how Swift package.swift files, are implemented in Swift. Gradle implements those in Kotlin. And so you write in whatever build logic that you need, and it has its own DSL for declaring dependencies and declaring multiple modules. And, more or less everything you have in a package.swift, you can accomplish in a build.gradle.kts file. And so what the, Skipstone plugin does automatically is every time you rebuild your application, we convert your Swift to Kotlin, we convert your Swift UI to Jetpack Compose. We also take your Swift Package Manager package.swift along with any dependencies, and we convert that into a mirror tree of Kotlin Gradle project builds. And so you wind up having this parallel structure that is automatically derived from your Swift build every time you build. So then you have this forest of Gradle build files that you could run manually if you wanted to. You just run Gradle build in the correct directory. But what we do is, as part of the template application that you create when you run the skip init command, we add a build phase into Xcode such that when you launch your application, it winds up invoking Gradle launch debug on the transpiled version of the Gradle project, so that every time you build and run your application on the iOS simulator or on the iOS device, the equivalent transpiled up-to-date Gradle project is compiled and run on your attached Android emulator or Android
Okay.
device.
So have you ever used like Tourist?
Yes.
So I mean, it sounds like basically their stuff is set up all in Kotlin, similar to how Tourist has the whole Xcode project set up in Swift, essentially, and then you can go from there. That's what I'm hearing. I don't know, but it sounds a lot like that, which is kind of cool.
Yeah, yeah, a little bit. No, we don't use Tourist on the side of how we create the
Right.
Xcode build file.
Right.
But
No, I just mean like the fact that you can create an Xcode project using Swift, you can create an Android project using Kotlin. So I guess that's what I'm just seeing the parallels there.
yeah, exactly. And that has the benefit too that, not only can you build and run this from Xcode, which is really the common development cycle that iOS developers will want to use, but you can also take that same, build.gradle.kts, and you can invoke it, you can open it in an Android IDE like Android Studio or IntelliJ. And all of these have built-in support for Kotlin, Kotlin Gradle files. And so that's how you can basically take that application and open it in Android Studio, and then you can have access to all of the Android Studio tools that you need, like analyzing the size of the generated artifact, running the debugger, and things like that.
So I think I've heard of the project, this Skip.Tools before, but what really intrigued me was the post I think you had on LinkedIn where you were showcasing Swift packages that are compatible. I'm a big fan of Swift Package Manager, as imperfect as it is. And it was cool to see like all these libraries that were available on like to use already on Android. How does Skip um how does it employ Swift Package Manager throughout its its development, and we'll talk about internal libraries that Skip has. But how does it use Swift packages in the development and transpiling operation?
So, we always say this project wouldn't have been possible a couple of years ago. It was really the advent of Swift Package Manager build plugins that made all of this possible. And build plugins are, basically a, plugin line that you add to your project dependency that is, it defines an action that can get run whenever you perform a project build. And that's really what unlocked the ability for us to hook right into Swift Package Manager's build process and be able to do things like, parse all of your Swift files and be able to convert them into Kotlin on every build. And so that really also makes it independent of Xcode at all. You can run this process, the build process, just using Swift Package Build on the command line, which is great for continuous integration as well, because for all of our packages, both our core packages like the Skip UI and Skip Foundation packages, but also for our external packages like Skip Firebase and Skip SQL and things like that, you can just build and test as part of a GitHub action, which is, has been fantastic for us for quality control.
So, I build a lot of my apps using Swift Package Manager, basically the code base, using something like Toist to then bring that in and use that to build an app. How would I move forward with some of my current apps to get those over to Android? If everything is basically in Swift Package Manager, should I still employ something like Toist and then run Skip.Tools on top of that, or what would you recommend?
Probably what we generally recommend is that you create and initialize basically a blank Skip project using Skip init. And what that winds up doing is it creates, so the core of everything is a Swift Package Manager package.swift. But when you create an application project using Skip init and pass in the app ID, it additionally creates both a Darwin folder and an Android folder. And the Darwin folder creates a app name.xcode project. And that's kind of an empty shell of a project. Really, all it does is it references that Swift Package Manager top level package. So in some ways, it's kind of an unusual Xcode project because really it's just all it's doing is wrapping a SPM project and then providing additional metadata like the application icon and the entitlements and all the extra stuff that needs to go into building a real application. But it is really sort of a hollow application, a hollow project. It doesn't have, I think it has one source file just because it needs a main method. But, other than that, it just really references the Swift Package Manager module. So generally, and that's sort of a very customized Xcode project that it creates. So we generally recommend that people create one of these kind of empty projects and then bring in their code sort of piecemeal into the application. And then it might be a iterative process, right? Because maybe not everything is going to transpile out of the box. And so, sometimes it won't be working on the very first build and run, but we provide you with a lot of guidance and, warnings and things like that if it doesn't build at first.
So let's say you do this. Where would you recommend somebody be like, this tool is great, but there's a few spots where you might want to actually write some Kotlin code. Where would you think? Where would that be the best fit, I guess?
Yeah. So we have in our docs is a platform customization guide, and there's a variety of ways of doing this, of basically dropping in custom Kotlin. And there's a lot of reasons why you would need to do so. There are plenty of we translate, a lot of Swift UI into Jetpack Compose, and we translate a lot of your foundation libraries into the equivalent Android libraries, for example, like URL and, file manager calls and things like that. But there's always going to be things that are very iOS specific that aren't going to just automatically translate into the Android world. And in those cases, the easiest solution is just to drop the equivalent Kotlin call right into your Swift code. And the way that we accommodate that is we have these preprocessor blocks that are just like pound if skip. And if you put code in there, Xcode will ignore it and the iOS build will ignore it. But we, it's part of the Skip.Zone plugin, will process that and pass that over to the generated Kotlin. So you can actually just drop raw Kotlin right into the middle of your Swift code, and then be able to work with it. And it looks pretty weird at first, just sort of like you're using Java idioms, right? You have Java package names, and you have sort of some Kotlin-ish, syntax. But Xcode is happy to ignore it on the Swift side, and so that's really the sort of quickest way to basically say there's this iOS specific call. There's no obvious, translation available for it. So I'm going to do this thing on the Android side, and I'm going to make, what I deem to be the equivalent call, and then work with that. And that's really the first level way of dealing with that. Then there's the second way, which is a little more elaborate. Sometimes it's not like one or two lines. Sometimes you have a whole, big Kotlin file of logic that you don't want to paste into Xcode, and sort of massage until the syntax works, lines up quite right. So you can also just drop in a Kotlin file into a skip folder in your Swift package manager package, and then that again will get ignored on the Swift side, on the iOS side, but that will just be brought straight into your Kotlin build, and then you can reference that from code within if skip blocks.
Oh, okay. So you can like build a class in Kotlin.
Yep.
And then reference that class in your if skip. Okay. Very cool.
That's right.
And
then there's a third, the sort of next level up is actually having a Kotlin dependency. I mentioned Skip takes your sort of network of Swift package manager projects and converts it into a Kotlin equivalent. It only does that for packages that support the Skip.Stone plugin, for basically packages where you had planned on having it work with Skip. You can also have any dependencies you want on the iOS side. Like you can depend on projects that don't have any knowledge of Skip or anything. But those won't exist on the Kotlin side. They won't be transpiled. They won't be, referenced. However, what you can do is in the Skip side, you can add dependencies just like you can on the Swift side. Dependencies
to Kotlin libraries.
Exactly. Yeah. And there's
what's
sort of
their
an
equivalent?
Their equivalent is called Maven dependencies.
Oh, so which is the Java one. Okay.
Yeah, exactly.
Yeah.
And so you basically basically say I depend on, com.google.firebase, colon 1.5.3. You put that in your Skip. There's a Skip configuration file on a per Swift package manager module basis called skip.yaml. You basically list those dependencies in there, and then in the derived Kotlin Gradle project, it will have the dependency on those libraries. And so then inside of, say, if skip blocks or inside of, your raw Kotlin, you can just import those packages and you can use them directly.
As of today, the day of recording, Giannis had posted the Swift on Android work group, and wanted to ask about that. But before I do, I do a lot of stuff with Linux, like Ubuntu or Linux, as well as the Apple platforms, and I know we've had Windows stuff for quite a while. Is there already any like preprocessor directives or anything with available not the available macro, but the available attribute that are specific to saying that a certain method is or is not available on Android? If that makes sense, that are either compile time or runtime, I guess, outside of Skip. I'm talking.
So there are, the Android work has been going on for, many years by, not just us, but a large community of people. There are some preprocessor checks. You can do if OS Android, then do this and, else do that. There is not currently, unfortunately, because that'd be really useful for us, there's not currently any way to annotate a function as being, or class as being available or not available on Android, similar to the way that you can do it on, tvOS, this is not available, watchOS, this is available. That'd be a great addition, something that not just Android people, but Linux and Windows people would also find useful.
Yeah, I mean, even Linux people, like I end up having to do like if can import as my workaround for that sometimes.
Yeah, that's what we do as
Unfortunately.
well. Yeah, we do if can import. Android is the name of the module for Android, packages. So you can do if can import Android. I wrote a blog post recently that's gotten some traction, mentioning that Swift Everywhere package about how you can get your package working on native compiled Android, and 90% of the time it's just adding in a if can import Android, then import Android, else if can import Darwin, else if can import
Right.
glibc, import glibc, and you
Yeah,
get a
yeah,
whole.
yeah. Yeah, that's a really good call. I like the one I'll do is like if can import Swift UI, for instance.
Yeah, exactly. Yeah, yeah.
Um so yeah, and then like on the Swift package, I bet you can't even say what Android version you support the Swift
No,
package.
you can't say no. It's still all that stuff is really limited to Darwin platforms right now. But that's one of the things that we really want this Android working group to really get underway with helping push is expanding those to support the other platforms.
Well, let's get into that. What are you looking forward to when it comes to the Swift and Swift on Android work reading group?
So I should prefix this by saying that everything I've been talking about thus far has really been Swift Skip 1.0, where everything is transpiled. And what, that takes your Swift and turns it into Kotlin, and builds it just like a regular, Android app. Everything going into it is going to be Kotlin or Java code. There's no native code at all. And that has been working, great so far. But as I'd mentioned, there are some limitations in transpilation. There are some limitations around generics. There are some sharp edges, like you can't have retroactive conformance to protocols for types outside of your current module. There's kind of a list of things that are just impossible to accomplish with transpilation. So that's one shortcoming of transpilation. Another one is that in order to depend on another Swift package from your transpiled skip code, that package also needs to be aware of Skip. It needs to have the Skipstone plugin being run and things like that. And not every package is going to want to do that. Not every package is thinking about Android or, really wants to bring in that dependency. And so for about the past year, we've been working on integrating natively compiled Swift on Android side by side with the transpiled Swift on Android. And that sort of complicates everything a little bit, because sometimes your Swift is turned into Kotlin and compiled to the Kotlin compiler. Other times your Swift is just compiled directly to Android using the Android Swift toolchain. And then what Skip winds up doing is using the Skip Fuse package, it automatically and transparently builds a bridge between your transpiled Swift and your compiled Swift. So that for, the common example is right now, if you run skip init for an, new application package and pass native to it, what it will do is it'll create an application, sort of a hello world application that's like a little CRUD app with create, read, update, delete on a little JSON file. And without native, that will create two modules, a UI module with all the Swift UI and sort of a data model module with model handling code where it is an observable view model, and it reads and writes for a JSON file and things like that. So in pure transpiled mode, those are both done in transpiled Swift that will turn into Kotlin. When you run that in native mode, what that will do is the Swift UI is currently still transpiled into Jetpack Compose, but the view model code is actually going to be compiled directly to Android. And then they communicate back and forth as using Swift observability, using the bridge that winds up getting automatically built. So what that grants you is your view model code, all of your model code, that can have any dependency on native Swift that you want. It can use Alamo Fire. It can use, the point free company, Swift snapshot testing. It can use basically any of these packages that are already building natively for Android, and unlocks that entire huge ecosystem, growing ecosystem of pure Swift packages that you can start taking advantage of.
That's pretty amazing. Yeah. So you think that's like pretty much the future is going with compiled as opposed to transpiled?
Yeah, in order to give real reach to all of your code, to have it be sort of true 100% compiled Swift, we do think that that is probably the future. For simple apps or apps that don't have a lot of dependencies, things like that, um, you know, people can perfectly, stick with the transpiled process that has been working so far. We've shipped half a dozen apps, and there are other people, many other people that are shipping apps today that use that approach. And that approach has a few advantages of its own, right? Not having to embed all of the Swift libraries means it's a much smaller binary shipped on Android. Debugging, that's a much easier story when it's all done in Kotlin and Java. If you have a crash in Swift and debugging that on Android, there's currently some challenges that we're going to be working with this working group to overcome,
Yeah.
where, you
I
see
mean,
these
are we talking Android support on Xcode? Like, I don't even know how you would get there, right? If you're going to step through a piece of pre-transpiled Swift, right?
Yeah. I mean, we'd love that. We've communicated with Apple that that'd be a great feature. I don't see that happening right away. So,
Right.
you can, if you open your project in Android Studio and you run it in a debugger, you do get some native support for that debugger. But, you've probably seen mangled Swift names, in the past, and they're not easy to digest or understand, and you can't jump to the line. And, so there are challenges with purely native code. But overall, we feel that as this technology evolves, which is currently still in early access tech preview release, but it's available and people are using it now. We think the benefits really outweigh the disadvantages, because it is real Swift. So you have true value types. You're really you're running real native compiled code. It's going to be more memory efficient, and you have access to this entire galaxy of wonderful Swift packages.
And going back to the question I had earlier about how does it differ, like we're talking about being a little bit more like Flutter in a way, as opposed to like the transpilation, which I don't think anybody really does, right?
Yeah, no, to my knowledge, I think there have been a couple of academic experiments with transpilation, but to my knowledge, we're really the only ones that are doing that level of, you can develop a full app using transpilation.
One thing I wanted to come back to was, as far as the transpilation is concerned, would anyone ever want to edit the transpiled code? Or would they ever want to commit it to their repo? Or is it something that should be done way behind the scenes and don't touch it, don't look at it?
We're happy to have you look at it. Actually, you can just open it right in Xcode and,
Right.
look at them side by side. And we have some map back line numbers when there are, the errors and things like that back to the original Swift. So we're happy to give you access to it.
Right.
But
But
we don't read back in changes that you make to it. We mark those files as read only, and if you unmark them and make a change to it, they're going to get lost the next time you build.
so the intention is to just let the build tool use it as part of the process. But I mean, almost now that I'm thinking about it, it almost seems like Apple, I guess, would be a good comparison. NPM or Node, where it's like, oh, this brand used to have browsers, right?
Yeah.
It didn't have TypeScript support, for instance. And you'd use
Yeah.
something like that to transpile it so it could actually be used in the browser essentially. This is kind of what it sounds like.
Yeah. A good equivalent is like TypeScript to JavaScript. You generally don't expect to be able to mess with the resulting JavaScript and then, affect the original TypeScript. Now, all that being said, though, Skip is a commercial tool, and, we sell the transpiler plugin. However, and the output of the Skip process is still your own code. And we have a mechanism for exporting your project. Just command this skip export. It takes your entire project and it creates a fully buildable, runnable Android project, that uses Jetpack Compose and everything. And it's completely separate from needing any of the Skip, build tools. And that's what we call ejectability. That basically means, like, say you decide down the road you don't want to use Skip anymore. You developed version 1.0 of your app, and maybe you decided I'd rather just go my own way and have a Kotlin team and take your app and go with that. You're perfectly free to take that resulting exported project and hand it off to your Kotlin team, and they can go their own way with it. It won't be pulled back into your single, Swift source base, but it is your own code to do with whatever you want.
Yeah, awesome. So I want to cover a couple of questions that we got from the audience. Danny Bart asked about, I'll say what he said. Curious how Skip handles Swift UI, UI kit representables, I assume Skip doesn't transpose, map kit, PDF kit, pencil kit. Is there a way to write Kotlin code for certain parts of your app in order to fill those apps looking forward to the pod? Looks amazing. You kind of answered some of the stuff already. I'll just kind of paraphrase. So UI kit, is that supported at all?
No, not the vast majority. A little bit of it is, like, we have some UI color and UI font, sort of the things that are needed for support. But the UI view representable, we don't have direct support for that because we don't transpile UI kit views. But what we do have is an equivalent on the Compose side called Compose View. And so when you want to sort of interface with more legacy views, Swift UI, you have legacy UI kit you want to interact with. Same thing on Jetpack Compose. They have their legacy Android views, not all of which have, they just call it Android views. There's no other name for it. They're the old school sort of, you write XML, views and you build them up. But there's a huge pool of these that have evolved over, a decade. And so there's the equivalent in Jetpack Compose where you can, insert old school, legacy Android views using what's kind of the Android version of UI view representable. And so what you wind up doing, and the way that we handle things like, say, MapKit, and things that don't, well, say MapKit recently did get a Swift UI view, but pretending for a moment didn't, or say, WK Web View, that's a really common one. What you would do is you'd use this if skip block mechanism where you'd say, if not skip, in other words, if you're running on iOS, do the UI view representable, and you put in a web view in there, and then you do all the stuff you need to do. It's sort of a complicated or large task. And then on the Android side, in the else if skip, you would use a compose view, and you would drop in a android.webkit.webview, and you would do sort of the equivalent, management, shuffling around of state and dealing with all that stuff. And it's something that people do very commonly using Skip, because that's one of the real selling points, is that, unlike frameworks like, Flutter or React Native, we're making a bridge as a gigantic and complex and very involved task. You can just drop this stuff right into your Swift file, and you can, start iterating from there and see it come right up on your Android screen. So even though it might be a little bit, complex and daunting at first, you can get pretty far just by dropping, code in there. We have an app that's actually available on the App Store and the Google Play Store called Skip Showcase. And that is more or less a list of, I think, all of the Swift UI, views, view types. There's a navigation list for, sliders and date pickers, which I'm looking at it right now, and gesture recognizers, geometry
This is
readers.
on the Google App Store or
It's on
Google Play Store?
Yeah. So it's on both the App Store and the Play Store.
Okay. Cool.
And it's really useful when people are evaluating Skip, because you can bring this app up, Skip Showcase, on both, and you'd be like, okay, what does a picker look like on both of these? And you can see exactly how the picker appears, in the user or the progress view.
So I wanted to ask, what if you add something that is not supported Android? What will end up in Android?
So it's whatever you wind up doing in the if not skip block. Like, maybe it'd be nothing.
No, what if you forget? What if you have just like, you throw in a map view in Swift UI and then you transpile it? What's going to end up happening?
It if you didn't guard it inside an if skip block, then there would be an error once you get to
A
compilation.
compilation error.
Yeah, compilation
Okay,
error.
cool. No,
Because
that answers my question. Yeah.
right.
I was just wondering at what point in the line would you get a warning? So that's
So we have a couple. We have at the build processing time, basically when the build plugin runs, when you kind of doing the pre-build, we do have a bunch of mechanisms for warning you as well when something is missing. So for example, if there is some SwiftUI view that we don't yet support, we mark that in Skip as being unavailable. So you'll very quickly get a message that says this API is not available, maybe a suggestion for what you can do. If you don't hit that, then you will wind up, when it tries to do the Gradle build and build for Android, you'll wind up with a compilation error, which might not be quite as friendly as the ones that we surfaced earlier on.
as long as it's not something that you're going to put on the Google Play Store and find out that way.
Right.
Like,
Oh,
I think
yeah,
that's
no.
fantastic.
Yeah. So unlike, say, like React Native, where, JavaScript, you hope you tested every possible runtime branch, you still do have a compiler going on here. So you're not going to just like wind up missing something and having a crash or a crazy error at
Right.
runtime.
I did want to, I do want to give you a chance to mention that there are some extra frameworks available with Skip. So stuff like Skip Web for doing specific web views and things like that are available. So
Yeah, we've got,
you do have some stuff to kind of make that bridge easier.
yeah, we have a bunch of packages that are, sort of commonly used by applications. You mentioned Skip Web. That's really common for dropping in an embedded web browser. And actually, that's a good package. And all of these are free and open source on GitHub under the Skip.Tools repository list. That's actually a pretty good one to take a look at if you're curious about how you have these parallel implementations between Android and iOS, because that is essentially just doing what I described, where you have a UI view representable on the iOS side and you have a compose view on the Android side. But yeah, so, we have like that. We have Skip SQL, which runs on top of, SQLite. So you can, write to SQL databases. We have Skip Firebase, which is actually a pretty interesting one, because Skip Firebase, we obviously did not reinvent the Firebase APIs. On the Swift side, we just run directly against the Google Firebase Swift SDK that they provide. We don't actually interpose ourselves at all. You just are calling the Google APIs directly. And then
is Firebase built into Android?
No, it's a separate package and download.
Really?
Yeah.
Okay.
So it does interface with Google Mobile Services, which is part of many Android distributions, but is also a somewhat separate component because, for example,
it's not like CloudKit where everybody gets CloudKit when they have
right. No, okay. It's not baked in 100% of the places. So, also in general, like Jetpack Compose is not part of Android as well. Like all of these things, unlike say SwiftUI, which is bundled as part of the operating system, all of these things are really brought in at build time and bundled as part of your application package. And so Firebase is one of those that is built in, that it's bundled in, not built in. And what we wind up doing with our Skip Firebase support is that, since Google is pretty good actually about having these two APIs be very similar in terms of just like type names and method names and things like that, our Skip support for that, really all it is just some really simple pass-through wrappers where we have a sort of a Skip side Swift type that is like Firebase, connection, Firebase analytics, Firebase auth, that really just passes these calls straight through to their Kotlin equivalents, which are in many cases named exactly the same thing. So it actually winds up being a fairly rote exercise to enhance that package. So that's another good one. We have another good example of Skip Bluetooth, which is almost completely user contributed. We started the package a long time ago, but never actually implemented something. But just a couple of months ago, someone came along and said, I need, Bluetooth, support through Skip. And they wound up just implementing a very large swath of the iOS Bluetooth SDK on top of the Android equivalent Bluetooth services.
Very cool. I wanted to get one other question out of the way from Adam Hill. He's asking, I'd like to know if there's any timeline on transpiling arbitrary macros, just not Apple specific ones. So I guess, I mean, I could try to answer this question, but I would assume there is no timeline because we're moving over to compiling. Um, so you do support macros, though. It does sound like
No,
none.
not on the transpilation side. So I think the question is maybe alluding to the fact that we do have built-in support for some of the built-in macros. I
Right,
mentioned
that's
them.
what I meant. Sorry, Apple's
Yeah.
macros are supported, but if you create your own macro, no transpilation.
Yeah, I mean, it's actually, we'd love to have support for that, but it's actually a limitation on the Swift build plugin system. We don't get access to the macro code before it's converted. Yeah. So there's not really any way that we can support arbitrary user written macros. However, in the native Swift compilation and the Skip.Fuse, version on your model side, we do support it. So because it's just regular Swift. So the answer is that in the transpiled world, we only support a subset of the of the ones that we've decided to handle, like observable. On the compiled side of Swift, we support any macros.
Okay, very cool. That makes total sense. Yeah, I'm surprised you don't have. I mean, they're already doing a transpilation and not transpilation, probably not the right term, but I would assume you would have access to the code after the macro had been applied, but it sounds like you don't.
Yeah, no, we only get it before. Yeah, we've raised it with Apple, and we heard an answer to that request. I don't entirely see how they could do it, actually. I mean, unless they're to change the entire order of how things are run in the build process. But it has been a shortcoming so far. One of the reasons why we are definitely pursuing the compiled angle as well as the transpiled angle.
Right, right. So if somebody wanted to use Skip, what do they need to do to get started? How much does it run for? And yeah.
So we have very generous free plan. Basically, we have an indie plan where you can use it to build, one app as long as you're sort of a small business or a small group of people. Build and ship one app for free, so you don't have to use it. You don't have to pay anything at all. If you are a small business, then it is a annual subscription, and it is $299 a year. And then professional for sort of a large organization, it's $999 a year on a per developer basis.
Okay. Before we close out, I did want to ask you about FOSDEM. You spoke at this conference. I don't think a lot of people know what FOSDEM is, especially here in the US. But it's very popular. I know a lot of people spoke from the Swift community. What is it? What'd you speak about?
So FOSDEM,
why were Swift people there? Yeah.
FOSDEM is an annual free open source software convention in Brussels. This was actually my first year there. It was a blast. It's huge, and it's totally free to attend. It was at the campus of a university in Brussels. And, there's all sorts of different tracks. There's, tracks about JavaScript. There's tracks about, a lot of server-side stuff. More or less any time that there's free and open source software, an ecosystem, you can get one of these speaker rooms, and these speaker rooms have various tracks. And this was the first year there was a Swift track that was going on. That was very cool. There were a bunch of very interesting talks, only some of which I was able to attend. But I think that was really exciting for sort of Swift to make inroads into, a community where historically people have sort of looked at it as a corporate, Apple only, just iOS building kind of language, and open it up to more like, oh, wow, you can build, a Linux server process using Swift. You can run it on Raspberry Pi, things like that. So I actually didn't speak on the Swift track. I spoke on an entirely different track. And it was actually about building app stores, specifically about the alternative app marketplaces in the European Union, which is a project that I've been working on for a while, actually unrelated to Skip, but is using Skip technology in order to create a single universal app marketplace for people to be able to distribute open source applications.
That's awesome. We'll have to put a link to that in the show notes as well.
Yeah, it's the App Fair project, and it's coming along. We basically that's how we're currently publishing our current example Skip applications through the App Store. So it's very nearly ready for ingesting other people's open source apps and being able to provide them to the entire world. And that's really the source of passion for me that really caused me to want to be able to create Skip, is that we want to make apps that reach the entire world, right? So not just all the devices, which for all intents and purposes is iOS and Android, that's essentially 100%, but also all languages and all abilities. So we have really good support for localization, internationalization in Skip applications. We take your XC strings translation files and we convert those over to Android. We have really good support for the accessibility APIs and SwiftUI. So, with just a single code base for the first time, really, you can take a single sort of premium polished iOS application and you can reach the entire global population, which is like 90% of all adults have one of these two smartphones. And that's what really makes it exciting for me, is the possibility that a single creator can finally reach, the entire market space without needing multiple teams and coordination between, a lot of different developing groups and things like that.
Yeah, that's amazing, Mark. It was so cool to talk to you today about Skip. I played around with it. It's pretty amazing. Pretty happy that I can build an app in Swift and post it on the actual Android phone. So I was super happy about that. Thank you. Thank you for coming on.
Thanks so much for having me, Leo. It's really been a blast.
Where can people find you online?
Skip.Tools is really the primary way of reaching me and the project. And then on the About page, you can see the links to my various social media.
We'll have links to the Skip showcase, your talk from FOSDEM, and the alternative store that you are working on. And yeah, definitely take some time, download Skip.Tools, give it a try. It's pretty fun. Thank you for joining me for today's episode. And if you're watching us on YouTube, please subscribe. I'd really appreciate it. And if you're listening to this on a podcast player, please post your review for this episode. Thank you so much, and we will talk to you again. Bye, everybody.